clear, if you follow the instructions step by step, you should be fine. Yeah, but we know a lot of details, we cannot put all the details in the project description, right? Yeah. So usually you can use this way. If some of the details I do not talk about, so you have some freedom to, use your own way to do it. Okay, just some reasonable, natural way to do it. Yeah, from my side, because if I do not put any requirement on it, so any way you do should be fine. Yeah, so that's the general principle. Yeah. All right, so here, based on the feedback from a few students, so let me talk about a few questions here. The first one, C.1, on data input and data validation. Yeah. So actually here, we do not have the data validation issue, yeah, but, some small problems. So I like to talk about a little bit. Yeah. All right. Data input. Yeah, so here, the detail part. So let's look at the data we need. Yeah, because we do polynomial evaluation. Okay, so let's look at. So here, to evaluate a polynomial, and our polynomial is in some general form. Okay, yeah. And we need to produce the data needed for this polynomial. Okay, yeah. So here the data. So let's look at what the data we need. First, coefficients of the polynomial. Coefficients. So that is the array, this array. Okay, yeah. All right. Second, the x value, right? Yeah. But some students also, talk about, because we ask our user to enter evaluation type, right? Yeah. Type of methods. Okay, yeah, type of methods. 0 exit. Method 1, method 2, method 3. Okay, yeah. So we can also include that part. All right, yeah. And this one, we generate, use a random generator or function. This x also by a random function. This one from keyboard, right? All right. So here, the question, all right. For A array, the range is in one, these integers, 100, from 1 through 100, positive integers. Yeah. All right. But we use our n 200,000 approximately. Yeah. So later I will explain this number. Yeah. So here, let's assume our polynomial degree is 200,000. Then one student asked me, because the coefficient value we can only choose from 100, but we have 200,000 plus 1 coefficient numbers we need to generate. Then we have a lot of repeated values, right? So here, no problem for repeated values. Repeated numbers in our coefficients. Yep. Actually, it's very common. When we write a polynomial, it's very common. Some of the coefficients can have the same value, right? It's quite common. And usually we do not require unique values for polynomial coefficients, right? Yeah. That's not a requirement. Yeah. So for the repeated values, numbers in coefficients, we do not need to worry about anything, right? Yeah. In our polynomial evaluation, we do additions, multiplications. We use repeated values. There is no problem. Okay, so we do not need to worry about that. Okay, yeah. So that's just but one student mentioned that, so I like to explain a little bit. Yeah. Other than that, after you generate coefficients, you put it aside, because you generate the coefficients before the user selects a method type. Okay, yeah. So when you start a program, you generate the data first before you ask a user to select from the method list 1, 2, 3. You generate the data first, because in that way, the generated data, actually, so here the data, all right, we mean coefficients plus x value. Okay, is used for all method selections. Yeah, because after that, yeah, so the situation is like this. When you run the program first, before you ask anything from your users, you generate the data first, the coefficients and the X value. You just store in your variables. Okay, yeah, ready for the remaining executions. Okay, then you print out a menu asking the user to select one of the three methods, right? So we expect the user select all three methods, 1, 2, 3, in any order. Okay, yeah. When they make several selections, you use the same data. Okay, and so here I mean same data for all selections. In that way, you can do comparison, right? In that way, your data keeps the same for all experiments. Then you expect to produce the same result. So we expect all those functions, all those methods to produce the same result. Right? Yeah. If you see, for example, when you run three methods, you generate three output numbers for the polynomial values. If you see some of them are different, then there must be an error. There must be an error. Oh, later there is a truncation error I need to talk about. Okay. Yeah, so let me delay, yeah, because here I already used almost all the space here. So there is a truncation error I need to talk about. Truncation error. Question, all right, yeah. All right, so the answer should be pretty much the same. Then, yeah, it's very likely, we cannot say 100%, but it's highly likely your answers are correct. Okay, yeah. And regarding the input validation, here you can see for the coefficients, you don't need to do validation, right? Because you generate the data in the range. That's valid, already valid. For X, X is in the interval between 0 and 1, right? Yeah. So we exclude 0 and 1, yeah, because that's too simple. Yeah. Exclude. Yeah, actually, in my description, I make a recommendation. So yeah, we do not need to use too many zeros here. Yeah. And the 0.99, for example, in this closed interval. Yeah. So you can generate. That means X value also valid. Yeah. Then the last thing, type of methods. Yeah, one student asked me, because you ask the user enter 0, 1, 2, 3, these four numbers are valid. They are valid numbers. But that student actually, that question actually pretty good. That question, student asked me, if a user enters a number out of those 4 numbers, number 5, number 10, or even a string, a character, things like that. Yeah. Then the remaining cases, the remaining cases, so not a valid number. Yeah. So you can handle by yourself. Not a valid number, you can output a message, right? Yeah, a message. Tell the user you need to select a number in, one of the 4 numbers. Just you have freedom. Okay, you can tell your user. Yeah. In my description, I didn't cover this point of detail. Yeah. So you just based on your natural understanding, so you make it complete. Okay. Yeah. So you give an option other than these 4 options. All remaining cases, you're putting one special case, and you prompt output a message, tell your users you need to select one of the 4 numbers. Okay, yeah, things like that. Yeah, in that way, yeah, because that question from this student actually is a good one, because you need to consider all the possibilities from your users, right? In real world applications, you need to consider all the possibilities. Okay, yeah. So that is this one. So you need to, yeah. Although from my side, so I won't test you this point. Okay, yeah. For me, I only enter 0, 1, 2, 3. I do not check you, other, garbage input. Yeah. 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 But for you, so if you consider this point, that's good. If not, so no problem. Yeah. Because our main focus is at the algorithm side. Okay. Algorithm side. Yeah. All right. So here, just to let you know, the details, how much details we need to cover. Okay. All right. That's the first question. Second question.